Hey guys, how are you doing? How's your day going? I'm just starting out your night. Hope you are having an amazing and beautiful day today. So in today's video, we are going to be talking about object-oriented programming. One of the best parts of programming. This was actually my final year seminar topic. But yeah, object-oriented programming is a programming paradigm based on the concept of objects, which are instances of a class. So an object is just anything that contains an attribute, which is the data and functions or methods that operate on that data. For example, you can have an object person. What would the attributes be? Gender, name, age. Then the methods would be like walking, talking, just that is just basically it. So now when you now have this object, this class actually defined. So class is a blueprint of an object. It's a blueprint for creating objects. So once you have this class defined, let's say the person class, you now create objects from that person class. So for example, you have a class like these are all the attributes a human being must have, and these are all the methods and actions a human being must be able to execute. Then you now create an object, you create a praise object, you create a whoever else's object, just keep on creating different objects to that class. The importance is that it encourages code reusability through inheritance, it facilitates code organization, and it promotes encapsulation. All these encapsulation are some, what do you call it? Is it features? I should have forgotten. But you have encapsulation, inheritance, polymorphism, and what's the other one? Oh wow, it's not good. It's not good. Okay. So I've already said what a class is. A class is a blueprint for creating objects. It defines a set of attributes and methods that the created object would have. So the syntax of the class, I think in one of our previous videos in this series, we already created a class. But let's create a person class. So you would have your class keyword, then you give the class a name, person, then you don't use parentheses, you just pom pom. Then you now define your initialization um method which is used to initialize the object attribute. So you just say def, that is creating a function if you remember. They have underscore init underscore parentheses. First of all, you have to have self because self personalizes it for whatever object is you're creating. Name, age, that should be enough. Then next we're going to now have self dot name. What is wrong with my laptop? It's going to be equals to name, and self dot age is going to be equals to age. Then you can now define some method. So let's just define one. Jeff, let's say talk. We're going to initialize it to the specific object that we have, and we're just going to print. Let's return it. Return. Oh god, my laptop is getting frustrating me, I swear. So why is it lagging? Return. Let's just use a formatted string. I just have the person's name is talking. Okay. Now after we have created this class, we now create an object from the class. And for the object to just say person one, let's do p1 since we're lazy. And we're just going to call the class person. Then we're now going to have parentheses. Now this parentheses when you now define for the methods. So for all these arguments that were passed here, excluding the self. So whatever argument you have here, you pass it. So the first one name, my name is Praise, and my age is none of your business. Well, let's say age is going to be I don't know 11. So once you save it, you can now carry out the method for the person that you have created. The way to do it is just let's print. Let's do for the person one dot. Okay, my laptop. God, please. This kind of pressure it's driving me insane. Person one dot talk. I'll just save it and we'll run it. Praise is talking. So Yeah, so we have been mentioning method. Method are functions defined within a class that operate on instances of that class. They can manipulate object data and perform actions relating to said object. Instance methods operate on instances of the class, always take self as the first parameter. So that is just everything we just covered here. Then the class method operates on the class itself rather than instances of the class. Use the add class method decorator and take CLS as the first parameter. So basically, if you remember in our last video, we talked about decorators, which allows you to extend the functionalities of a class or a function without actually modifying it. So basically, what this class method decorator will do is, if let's say, for example, we have our person class, but let's just start the person class as fresh. So let's say class person, and let's say now, let's assume we have so many other things going on here, but there are certain actions where we want to categorize by gender. So we can have, let's just say, an example: gender is going to be equals to female. We're just focusing on female. Maybe it's a female school or whatever. So we'll say female. Then we're not going to define our function. Before we define this particular function, let's have class method. So you can still have other functions going without calling this decorator needs. But let's say for this specific one, let's do talk. For example, let's say there was a world where only women were allowed to talk. Then the parentheses we're going to have CLS because we have the class defined there. And now we're now going to return whatever you want to return. But the way you now reference it is now going to be a bit different. So we're just going to say everyone talking is a, we now have our curly brace. Sorry that my laptop is just misbehaving. CLS dot gender, and we'll just print the class, which is person dot talk, which is the method. Don't forget your parentheses, save it and run it. Everyone talking is a female. Now, if you want to create, if let's say you want to create conditional kind of ones that send give out return boolean responses, you can use static method. So let's say, for example, let's just use this person that we're already working with. So let's say in the person class, we have a static method, right? I'll just check, let's say for some reason, I want to check if the user's name is all in alphanumeric. I'm just giving an example. So I'll say is underscore person underscore name. Then we'll just pass what it is we want to get from them. Name. Then we're not going to return. So you just do run whatever test you want to run here. For example, name dot it is giving us a suggestion starts with, should we use that? Let's do that. Names dot starts with P, for example. Then we'll now print person, just copy it. It's person name. Let's just search for person name that starts with P. Let's use my name. Let's do that in small letter because I did not count for that. It's case sensitive. It's going to pass through. But had it been the name didn't start with P, it's going to pass false. So there are still some other types of decorators that you can implement within your class. So you can just go and read on that. In the blog, I'll try to add a few more. But yeah, inheritance, I don't think you need anyone to explain what inheritance is to you. Inheritance, you inherited from your parents, you inherit wealth, you inherit physical structures. Inheritance is a mechanism in object oriented programming that allows a new class, which is a child class, to inherit attributes and methods from an existing class, which is the parent class. It promotes code reusability and enables hierarchy class structures. So let's say we want to do inheritance. So let's just redo our person class. Class person, and we're going to just initialize it. So def underscore underscore init underscore self name. Let's just have that for now. Okay, age, whatever. Initialize all these ones. Self dot name is equals to name. Self dot age is equals to age. Let's add our talk method. Def talk. This messaging me. Def talk self. But now we're going to be a little bit different. So in when you have like subclasses can kind of like make changes to certain methods. Like for example, now certain people will talk different, so you don't have subclasses of what they would say. So we'll not initialize that here. Instead, when they try to run it without inheriting from a child class, we'll just pass an error to them. Let's raise a non-implemented error. And we'll just pass an error message. You remember when we are doing try and accept, I talked about raising functions or raising an error. So just say talk method implemented. Okay. Now let's define classes. We can do two, but let's just do one. So we'll just say class. So this new chat class should be for females. Because why not? Female. But now if you're inheriting from a child class, they would have a parenthesis. And within parentheses will now be the class that you're inheriting from. Yeah? Okay. Then now we'll now just take this method that we want to implement and now implement it here. Def talk self, and now we can now control what the person says. So we can now return ugh, and I hate typing. I will say self.name. So even though name wasn't initialized here, we can still access it because it's inheriting from that person class. So when you are creating the class for this person, you are going to still pass in all the arguments that you'd have needed to pass if you were just doing it person. So let's just say I am my name and I am a lady. Because why not? Now let's initialize. So we're just going to say person one is going to be equals to female. Parentheses are not going to pass name and age because that's what we're asking for. You can see it's already telling us name and age. So just say for name we do praise. And for age we do 11 because why not? And we can now print out person one dot talk. Save that, run it, and praise and I'm a lady. Isn't programming so fun? So exhilarating. So there are different types of inheritance. There's single inheritance, which is what we just did now, when a child class inherits from one parent class. You have multiple inheritance when a child class inherits from multiple parent class. Or have multi-level inheritance when a child class inherits from another child class. And then there's hierarchical inheritance, which is multiple child classes inherit from one parent class. Like if I create class mail now, but you all can just go and research that on your own. Now, the last thing I want us to touch on is Dunder methods or magic methods. So Dunder methods are also known as magic methods, a special method in Python that starts and end with double underscores. You have been seeing it. We did um init, we did str, we did repr. So these methods are automatically invoked by Python in certain situations. For example, now if you start, okay, I don't have any Django file open now. Well, I would have shown you, but if you start working with Django, you would have like files where if your folder you just create an init.py file. But that's what I did for now, Sha. So command under methods are init, which initializes a new object, str, which returns a string representation of that object. Like remember the video, I can't remember what video that was, but it was in this series, one of the first or second video we did, where I said if you want to display it, like let's say for example you have an object, if you're just going to call the object, it may not look presentable. So you use your str methods to kind of like polish it up and make it look presentable. REPR, which we also talked about, returns an unambiguous string representation of the object. Remember, yes, it was when we were talking about DSA that we created our trees, and I think also did one for I can't remember, Sha, but we created, and with the way it shows when you printed that was not looking nice. So in order to make it look like an adjacent list, we first did an REPR to describe how we wanted to do, then we did the extra to actually now handle display. LEN returns the length of an object. Get item allows indexing into the object. So should we do some examples? Let's go back and visit our function. Let's just get rid of all these ones here. And let's just have our person function. Alright, so we already have our init running. Let's do one for string df underscore underscore str. Yeah, I think if you do the underscore underscore, you still see more examples that they're giving you. So we can just return formatted string. When using formatted string, I keep saying it's not compulsory. It's just a habit that I have kind of familiarized myself with. So just say self.name is self.age years old. Oh my god, it hurt me. Then we can do, let's just do all the ones I listed. Let's do learn. I'll just return learn for the self.name. Okay. And let's do get item. Def underscore get. And we're going to return self.name key. So now let's create an object for it. So P1 is going to be equals to person. We're going to pass a name, praise, and we're going to pass an age, 11. And instead of printing like a method, we're just going to print the whole class. So let me just cut this one first so you see how it would look before we implement all this. So let's just print. This is how it's going to look before you implement all those things. It's just showing us the location where the object is stored, right? Now let's put this. Now is the string function that is going to act here now. So let's run that. And now because we have the str is now going to say praise is 11 years old. That is what this string is for. Then now if we want to now test the len, we're going to print len bracket the object, and at the same time if you want to index it now because you have this the script, you can just do print parentheses p1 and you just access it the way you would when you were trying to index for a string. So you can pick any index of your choice, and voila. So yeah, the other methods basically just allow you to define how the objects of your class should behave in built-in operations. There's like operations that are default operations for Python, like all these things we just did now. You can do them if you're just working with like list and all this sort. But when you start implementing it into objects, it tends to be a bit tackier. But yeah, that's all for this video. If you have any questions, always feel free to ask in the comment section below. I'm always going to be down here responding, and let me know what you want me to cover next. This is still, I will always remain everything Python, and hopefully by the end of this tutorial you'll be able to proudly call yourself a Python developer. See you guys in the next video. We'll start going into packages. I think, yeah, that should be for the next video. Packages. See you guys there.